I'm Meyer and I run a climate site called ClimateSkeptic.com. Just to answer questions early on, I have an equivalent climate degree to Al Gore's, which means I don't have one, but I did actually get A's in college, and I did actually study a technical degree. My degree is in mechanical and aerospace engineering, and my specialization was in control theory and the stability of dynamic systems, topics that tend to be at the very crux of the arguments for and against catastrophic man-made global warming. This presentation was written for the skeptic side of a number of debates I've participated in. Unfortunately, of late, I guess a lot of strong global warming advocates have taken Al Gore's lead and don't debate anymore. So I'm going to have to do their part too. I'll begin by quickly presenting the case for catastrophic global warming, and then I'll talk about the science behind the skeptics' position of why man-made warming almost certainly will not be catastrophic. The word catastrophic is important. It is why I've labeled this presentation Catastrophe Denied. That's because we're talking about not just global warming theory, that name is incomplete. We're talking about catastrophic, man-made global warming theory. All three of those pieces matter. A lot of skeptics have been positioned as deniers, mainly because that name evokes the term Holocaust deniers. Using this term helps position skeptics as somehow beyond the pale of civilized society, espousing views that aren't really fit to be listened to, or as some have suggested, don't even qualify for First Amendment speech protections. It is a way of avoiding actually addressing skeptics' arguments and pigeonholing skeptics as folks whose views don't need to be examined. But really, to the extent that I'm a denier, I don't deny that the world has warmed over the last 150 years. I don't even deny that man may be helping to contribute incrementally to that warming. What I deny is the catastrophe. And so in this presentation we'll see that yes, there has been some warming over the past century or so. And yes, man-made greenhouse gases may have contributed somewhat to this warming. But man-made greenhouse gas warming is likely to remain at trivial levels, less than 1 degree Celsius over the next century. By the way, I know that global warming has been rebranded as climate change, but marketing is not science, and the warming matters. We're going to talk about it later, but recognize that no human being that I know of has ever suggested a method whereby CO2 causes climate change except via warming. If we don't see the warming from greenhouse gases, then we aren't causing climate change from CO2. So let's talk about the case for global warming. For those of you who don't know the basics, I'm going to talk about CO2 and how it can cause warming. We're going to talk about how scientists reach catastrophic temperature forecasts, and then we're going to talk about other climate changes that may or may not result from such warming. The little thing in the upper left with the C's and H's connected is a representation of a hydrocarbon molecule. Almost everything we combust for fuel is a hydrocarbon. The natural gas that we use out of the pipeline is one carbon with 4 hydrogens. Coal is a whole bunch of carbons in a chain with the hydrogens attached, and gasoline and liquid fuels are somewhere in the middle of that. Combustion is the process of breaking up these molecules into their component hydrogen and carbon atoms, and then combining these with oxygen. Hydrogen combines with oxygen to make H2O, or water, and carbon combines with oxygen to make CO2, or carbon dioxide. And of course, this combustion process produces heat because that's the whole point of it. We want to get useful work out of the combustion. By the way, there's really no difference between this and what goes on in your body when we metabolize food. It's the same basic process. That's why your body breathes in oxygen, expels CO2, and produces heat. Because basically it's a kind of combustion in your body from the hydrocarbons in your food. The last few days, the EPA has officially named CO2 a pollutant under the Clean Air Act. But CO2 is different from most things that we've called pollutants in the past, because these other pollutants were not necessarily inherent to the fossil fuel combustion. The Clean Air Act was aimed at things like sulfur dioxide and nitrous oxide and ash from smokestack emissions. These were pollutants that resulted from impurities in the fuel or from inefficiencies in the combustion process itself. But CO2 is different from all these other pollutants because all those other compounds are ancillary or accidental. They're not fundamental to the basic combustion process. But CO2 is fundamental to hydrocarbon combustion. Unlike other substances we could filter or design around, the only way not to produce CO2 is to not have combustion. And that's why reduction of CO2 is orders of magnitude more difficult than was elimination of previous pollutants that we've tackled. So what is the greenhouse effect? I will try to explain quickly, and for those who really understand this, I already know I'm oversimplifying. Just bear with me. To begin the process, as you see here, the Earth is warmed by incoming radiation from the Sun. The Earth then re-radiates this as infrared energy back into space, as shown here, on many different wavelengths. These two sets of radiation, one into and the other out of the Earth, must roughly balance, because if they don't balance, the temperature of the Earth is going to evolve over time to make them balance. So think of temperature as always changing to try to force these two energy flows to match. If, for example, more radiative energy suddenly starts coming in than going out, the temperature is going to go up until the outgoing energy increases and brings the system back into balance. Now we add a layer CO2 to the atmosphere, which I've drawn in pink. CO2, like other greenhouse gases, absorbs some of the radiation that's going back into space. Not all of it. It only absorbs, as you can see in this picture, some of the frequencies. As you add more CO2, more of the radiation returning to space is absorbed. Eventually, though, the CO2 has a diminishing effect as its ability to absorb radiation becomes saturated in certain frequency bands. The analogy that is often used is like painting a window. You put one coat of paint on the window and a lot of light is blocked, but it's still translucent. You put another coat of paint on the window and there's still a little light that gets through. But you put a third coat of paint on it and nothing gets through. And then further coats of paint have no effect on the light transmission through the window because all the light is already blocked. CO2 is a little like that, working as a diminishing return. Later on, when we look at a curve of CO2 and its effect on temperature, you're going to see that CO2 that's already in the air has a bigger warming effect than CO2 that we'll add in the future. In other words, each additional molecule added has less effect than the last. Finally, CO2 re-radiates the energy it has absorbed. Some of it goes back into space where not much happens because that's where the energy was headed anyway in the first place. But some of this captured energy gets radiated back down to Earth. And so the effect of the warming comes because radiation that is leaving the Earth gets absorbed by the CO2 and some of it gets sent back down to the surface rather than continuing on into space. This becomes an additional energy flux or forcing on surface temperatures. And that's how CO2 or any other greenhouse gas works. This is a chart we're going to use quite a bit. It's simple, but I just want to make sure that we all understand how it's laid out, so I'm going to walk you through it in detail. The key question in climate is not whether CO2 causes warming. If you want to talk about settled science, and people really overuse that term, but the portion of anthropogenic global warming theory that really is fairly well settled, even to most skeptics, is that CO2 does cause some incremental warming. This can be demonstrated with careful experiments in the laboratory. Further, we know this to be true in a macro sense, as the Earth would be far cooler without greenhouse gases to make our climate more congenial. So CO2 certainly causes some warming. The question is, how much? Or more specifically, how much warming is caused by small changes in atmospheric concentrations of CO2? The CO2 concentration of an atmosphere right now is about 385 parts per million. On our graph, we will put the concentration of CO2 in the atmosphere on the bottom axis, running up to values of about 650 to 800 parts per million, which are estimates of possible atmospheric CO2 concentrations by the year 2100, presuming we do nothing legislatively to limit fossil fuel combustion. I think a lot of people struggle to visualize just how small 385 parts per million really is, so I'll demonstrate it with an example. 385 parts per million is the equivalent of 0.0385%. If you were going to fly from Los Angeles to New York, what would be the equivalent of 385 parts per million of that journey? In other words, what would you be flying over once you were 0.0385% of the way to New York? The answer is that you'd actually be only halfway down the runway at LAX. Hopefully that gives you an idea how small 385 parts per million really is. I should note that there are skeptics who do not think that man is actually increasing the CO2 in the atmosphere, that the increase is mainly occurring as a result of temperature increases rather than vice versa. Since I'm not an expert on the CO2 cycle, which is horrendously complex, I don't find this a very productive way to argue global warming. I will assume that most of the increases in CO2 are in fact anthropogenic or due to man. There are other lower hanging fruit than this in taking on catastrophic man-made global warming that I want to address. So back to our chart. We looked at CO2 concentration on the bottom axis, and on the left axis we will put the global temperature increase expected for a given level of CO2. Often we will use something called temperature anomaly rather than an absolute temperature. Don't worry, the exact numbers don't matter as much as the changes over time. Besides, scientists actually have an easier time saying how much the world temperature have changed over the last 10 years than they have in actually saying what the Earth's average temperature actually is, or whether a global temperature even has any meaning in the first place. One way to think about it, scientists may not know what road they're driving on, but they can keep track of how far they've driven down that road.